Excellent. Well, thanks, Marianne. Greetings all. Joseph Kursky here with you for round 2, session number 2 in Mapping Our World. How is everybody doing? Hope everybody's doing well. Thanks for joining us again. I really had a grand and glorious mappy time last time, and I hope you did as well. Just as a reminder, and I think we might have Susan joining us for the first time, I'm not sure, but just sort of a recap then, especially for maybe you've got a lot going on between last week and this week. We started with talking about how relevant maps are to our 21st century world. We talked about these questions here. Haven't all the maps been made? Just ever so briefly, remember we talked about no, because of the following reasons. One, people want to map things at higher resolution than ever before. Back in 2000, we started to see 1 meter resolution satellite imagery from various sources. And then after a few years, people were like, can we have anything finer than that? And now we've got imagery coming in from drones or UAVs and also satellites that are smaller in size and able to take higher resolution images of the planet. And as well, we've got something called LIDAR, light imaging detection and ranging, LIDAR imagery from aircraft, which actually sends out a pulse, a signal, and it gets a bounce back from the surface. And from that, we can actually make really high resolution 3D maps of trees, buildings, terrain, canyons, mountains, etc. So for that reason alone, no, all the maps have not been made because people are wanting to map things at higher resolution. But number 2, they also want to map things that they haven't mapped before. We talked ever so briefly about some of those sort of frontiers in mapping. One of them is the human brain and other internal organs. Medical mapping at very high resolutions, as you can imagine, is a big deal in the medical field and beyond. So people are wanting to map new things that they haven't ever been able to map in the past. And out on the landscape, people want to, for example, have a very fine mesh of, for example, water quality and how it varies across a wetland, let's say, or the habitat of certain species or invasive species like purple loosestrife or zebra mussels, those aquatic things that cling to boats. And that's why you see those empty all your boat water cavities before you leave the reservoir type of thing, because they migrate in those water cavities in boats, and then they get into other estuaries and displace native species. So they're wanting to map themes or topics or issues that they haven't mapped before, and they want to map things at higher resolution. And then the third thing we sort of touched on with our hurricane mapping, as you remember last time, is that people want to map things in real time or as near real time as possible. Where was that earthquake 10 minutes ago? What is the water, the gauging station reading at the stream downstream from my house right now or 5 minutes ago? And what is it like, halfway across the world or halfway across the country? So that's sort of near real-time or real-time mapping from the Internet of Things, or the IoT, is becoming quite important in science and in mapping. Not only earthquakes and weather and other things that we touched on last week, but also traffic. I think we touched on this last week. When you're going down, for example, a road and you've got your mapping tools and you want to find out, how long is this traffic jam going to be? And you look at that, for example, Google Maps or other mapping tools, and you see that red segment on the road and it stretches on for another 5 miles, okay, this is going to be a while. How does that data get onto your mapping device? It's not a bunch of lines, those cords that are draped across the road that you've seen in the past, I've seen in the past, that are recording traffic. That actually comes from 1,000 people, all with a mapping device like yours, turned on, and the location-based services are on their phone, and it's sending a signal to that mapping service that X number of thousands of people are moving at 10 miles an hour. And so therefore the road gets colored red because of, basically it's crowdsourced. It's from you and I actually contributing that data. So people are wanting to map things in higher resolution, different themes that they've never mapped before, and also in near real time or real time. And I mentioned the traffic, stream gauges, earthquakes, but also wildfire perimeters. right? Those are fast moving and they're ever changing, right? So people want to be able to know what's the perimeter on, for example, this mesa behind me that was on fire in 2020 for several weeks. People wanted to know what the perimeter of that wildfire, this is just north of Grand Junction, my homeland, behind me. So wildfire perimeters, another fast-changing phenomenon, are wanting to be mapped as people want to have things almost instantaneously. This sort of a in-demand generation that kind of applies to mapping as well. People, rightly so, want to be able to map these things as they're happening. So that's another reason why all the maps haven't been made. And also, when you think of other new frontiers, we didn't have a high-resolution map of Mars in the past. Now we do, because we had to figure out where the Perseverance lander would land last year in spring. And maps of Io and Ganymede, Callisto, the asteroids and some of the asteroids in the asteroid belt, etc. So mapping other planetary bodies as well as our own moon in a higher resolution format. And then secondly, we kind of grappled with this a little bit, but are paper maps still relevant? And I made, I hope, a compelling case that yes, paper maps are still relevant. It's important to read signs on the landscape so that when you're out there and your device fails, because it probably will at some point, right? You won't have cell reception, your app won't work, your mapping or your topographic mapping app or your trails map won't work for whatever reason. Your phone will run out of battery or you won't have connectivity or for whatever other reason. So paper maps and reading signs on the landscape about where rivers drain, where north is, et cetera, are not just a nice thing to have, but we talked a little bit about, we've all seen reports of someone wandering around in the mountains of Colorado, for example, or in other places in the world, and being ill-prepared to read paper maps and also the signs on the landscape. And so they get into dangerous situations that could actually threaten their own life because they are only relying on the digital maps. Digital maps are very useful, but it's important to have a backup. So paper maps are still relevant, and they are interesting tools still. Not all of the historical paper maps have actually been scanned or digitized. So you can't get a digital copy of every single map that's out there. There's a lot of paper maps out there. David Rumsey, one of my colleagues, if you go to the David Rumsey map collection, for example, online, take a look at some of his. He's a private map collector in California, and he actually placed many of his maps online, but he's got a whole bunch that aren't online that are still locked up in paper form, and they may be in a drawer, they may be hanging on a wall somewhere, but paper maps are still important and relevant. Also, number 3, how can maps help us solve our 21st century challenges? We spent quite a while on that, not just with our hurricane mapping, but we talked about, look, we've got all these complex issues in our 21st century world, ranging from climate to health to population change here in Colorado and elsewhere, right? We've got water issues, we've got energy issues, we've got severe, lots of people moving to Colorado, rightly so. It's a great place to live, but where's all the water going to come from? Where's all the energy going to come from? Where are the transportation needs going to be coming from, et cetera? So all of those sorts of things, ranging from that to supply chain issues that we've all encountered over the last 3 years, especially with COVID. Why can't I get this? I used to be able to get this. Well, okay, there's supply chain issues around the world. Your phone is a perfect example, right? Where did all the minerals come from to build that thing? Where, if it can't be manufactured, it's actually got to come out of the ground. So how do we get the things necessary for the battery and for the case and all that kind of stuff? And then how is it going to be delivered, and where's it going to be transported to and from, and how's it going to get into your hands? So supply chain issues, health, water, energy. Look at all the UN Sustainable Development Goals, for example. Every single one of those is spatial in nature. It has geographic implications. It has relationships across space and time. And so we can understand those issues and indeed, on a hopeful note, solve them with mapping technologies. So those are some of the questions we grappled with last time. And just to remind you folks, I've got a plan for today. But it's your workshop. We love the Academy for Lifelong Learning, and their whole philosophy is, let's all learn together. I learn things when I teach. I know many of you have been instructors in the past or at present. You teach people how to do things that you know how to do. And it's a wonderful thing, right? Because you gain so much from teaching. And that's why I'm in education. I love interacting with folks like you, and I always learn things. I learned some things last week that I hadn't thought about before. So Anyway, the idea though is that let's make it relevant and useful for you all. And we had some good interaction last week. Let's keep that going. Ask questions. We've got a small group here. Feel free to interrupt me. Put your audio on, put it in the chat box, etc. Marianne will be monitoring all that stuff. So let's make this incredibly fun and useful. Also, I promised we'd do this this week, and we are going to talk about, hey, Joseph, these are really fascinating tools. How do I do that? How do I make my own maps? How do I share those, etc.? So we'll talk about that as well. Okay, another thing that I just wanted to kind of bring us up to speed here. Last Friday, we sort of ended with our favorite maps and map-related, geographic-related books. And I started sharing mine. Some of you shared yours, and that was a wonderful discussion that we started to have together. I wanted to start here with a couple of things, one of which was in the homework. And some of you are like, hopefully not panicking. Uh-oh, homework? Yeah, actually, Marianne and I sent this out a while back. And I'm going to go to the two mapping applications that we had in the homework, realizing that you may have touched it when we sent out the email. And if not, no worries. You've got busy lives, and that's understandable. But I think they're two compelling maps that we really should take a look at because they're very relevant to our west, Mountain West area that we're all inhabiting. And number two, they're, I think, good examples of what modern maps are, help us to understand patterns, relationships, and trends. So I'm going to start with something called the Living Atlas of the World, livingatlas.arcgis.com, the ArcGIS Living Atlas of the World, and maybe Marianne put that in the chat box. She's always so good about that. But the Living Atlas of the World. Remember, I was saying last week that one of the transformations over the last few decades has been the transformation from just a few people in science and mapping agencies being able to make maps that many people would consume, and private companies too, Rand McNally and others, National Geographic, although they're sort of a combination private company and a nonprofit. But anyway, the point is, these few organizations and the people that work there were really the only ones that had the technology available to them to be able to create maps that you and I would consume. And as I mentioned last week, I had the honor of actually working for the Census Bureau and U.S. Geological Survey before I started working for Environmental Systems Research Institute, where I work right now. It's a mapping company. So these are mapping organizations. But the good news is now that we've got these tools in the cloud, in the online environment, where anyone can actually make a map. That's good, but it's also lends to the point that I was bringing up a couple of times last week is how do I know if I can trust those maps online? If anybody can create one of these, including many of the middle school students I work with, and they're very bright people, but maybe they didn't do all the research that you and I would do. Ditto for someone who's our age, right? And did they do the research? How do I know if I can trust this map? So because it's an open platform, these mapping tools, for example, ArcGIS Online, which we've been looking at quite extensively over the last two sessions, there is a subset called the Living Atlas of the World. Now, the Living Atlas of the World is, again, an authoritative subset of everything that's in ArcGIS Online. ArcGIS Online has literally, in the time we've been talking, probably hundreds of things have been put up into that platform. Hundreds. There's over 1,000 things per day that get loaded into that, 1,000 maps and mapping applications and map layers. There's nobody at my organization that says, hey, wait, you can't put that data up there. As long as they sign in, they get an account, and we can talk about free ways to get an account, they can put data up in that platform, just like Google Forms or Google Drive or Dropbox. Of course, I do pay for Dropbox. I pay for extra capacity, but anybody can get an account in those things and put content there, right? Nobody's saying you can't put that content there. So same with ArcGIS Online. It's a completely open mapping platform. But a subset of that, because people say, hey, I want an authoritative source that's coming from science and mapping agencies, Colorado Department of Agriculture, the USGS, the Ordnance Survey in the UK, the World Health Organization, the Center for Disease Control. Those people, those organizations are putting mapped content in this Living Atlas. They have to go through some metadata rigor. They have to populate and say, where did that information come from that we're putting online? How often is it updated? What's map scale was it created at? Local, global, somewhere in between? Who is responsible for curating the data? Where did the data originally come from? What manipulations were done on the data before I got into this map format, et cetera. They have to populate the information that's behind the map and the map layers. So a subset of the ArcGIS Online is this thing called the Living Atlas of the World. Does that mean the Living Atlas is perfect? Well, no, because remember last week we talked about the Earth being an oblate spheroid. I know it sounds a little bit geeky, but we're going to get into it just a little bit. It's wider around the equator than it is around the pole, right? So it's not a perfect sphere for one thing. And also the only completely, and even that's not really a completely accurate map, but let's say you made a map of your kitchen table. If you made it at 1-to-1 scale, you could make a 1-to-1 scale map. It'd have to be a big piece of paper, right? A big butcher block piece of paper. But you could make a map at 1-to-1. But anything bigger than a kitchen table, it would almost be impossible to make a map at 1-to-1 scale. So sometimes, well, 99% of the time, maps have to be generalized, right? We can't make a map at the same scale of Colorado. We wouldn't have a big enough set of arms to hold it all. So maps have to be generalized, things have to be put in, things have to be left out on purpose so that there's clarity. You can't put every single ridge, every single water well, even in Colorado or even in Denver County in there, right? Every single house. No, you've got to generalize things. You've got to selectively symbolize things. You've got to classify data in various ways. So maps are representations of reality, very useful representations, but representations nonetheless. So they all have, for those reasons that I just mentioned, the projection that you're casting the three-dimensional Earth onto a two-dimensional paper map or a two-dimensional computer screen, or even a 3D map that you can make online with a set of geographic information systems tools. Even those have to be distorted. They have to be recast or re-symbolized so that we can actually understand what we're mapping. Even that landscape behind me, if we were to map every single ridge and every single tree, that would be very confusing and wouldn't be able to understand it. Maps are representations of reality, imperfect but very useful representations. So all that being said, even this data in the Living Atlas of the World is a imperfect representation. It's about 9,000 layers of content. Again, thinking about being critical of data. You don't believe everything you see on the web, right? Hopefully you're saying, no, I don't believe everything I see on the web. Same thing with maps. You shouldn't believe every single map that you see for various reasons, some of which we've already talked about and others we'll talk about today. So in this Living Atlas of the World, there's something called apps. If I click on apps, this is a subset of mapping applications. And there's several that are, I think, really, really useful and fun to get an idea of what's happening around the planet. And I'm going to start with the Drought-Aware app. This is, as you can see here, an interactive experience to examine past, future, and present drought conditions for the U.S., along with potential impacts to population and agriculture. So if I click on View Application, it's going to pull up, and this is one of the two items in the homework, the Drought-Aware app. Now, because we're limited on time, I'm not going to extensively look at this metadata, the information that tells you who created it at NOAA, census, et cetera. Why was it created? How often is it updated, et cetera. But just at one glance, so I encourage you to do that. At one glance, though, we can see, you know, what's the situation? Wouldn't it be great if we had a information about this map? So, okay, if we go to home here, you know, every map has got sort of a default view, a default map extent. And in this case, obviously, it's the 48 states, but, you know, we could click on Hawaii and Alaska and go there and Puerto Rico too. So, but I'm going to go to the default view, which is the 48 states. And by the way, since this is all in a geographic information system, if you pan to the southwest of California, Hawaii is in its correct position, right? A lot of paper maps have Hawaii and Alaska somewhere in northern Mexico just to fit them on that paper map. But in this case, everything is actually referenced to its true geographic coordinates, and that's why you've got Alaska and Hawaii in this actually a correct position. And so same with Puerto Rico, right? We could go out there and take a look at that. Anyway, the point is we've got a default map extent for this. So, okay, if we take a look at this, let's go ahead and, this color here in southwest Kansas, remember, this is tied to a geographic information system. So not only do you have a map with colors and symbols and so on, but you also have information behind it. So in this case, the map behind it, the data behind the map is really insightful, because you see it can go back, you go back in time for 20 years and look at drought conditions and what the situation is now, unfortunately, versus what it was like X years ago. It looks like, hey, in 2018, it was pretty bad in Southwest Kansas, and unfortunately, it's bad in Southwest Kansas now. We've got, every time I look at this, and every time you look at this in the future, it'll change, right? Depending on, according to this data, and that's a phrase we always have to use, according to this data and this map, it's going to change depending on the sources that are feeding it from these three agencies here, U.S. Department of Agriculture, Census, and NOAA. So, okay, that's interesting. And look, we've got a legend up here. If you click on the identify button, you've got this sort of tan to deep red sort of thing going on here. So you've got that going on. So you've got a legend here, and I'm going to close that legend. But the point is, we've got, I think, a bit of encouraging news that almost all of Southwest Colorado was in either the next to the most severe or the most severe. The last time I looked at this was, I think, in August. Now we've got a little bit of a better situation, especially in central Colorado, which is good. We must have had some snowfall up there. Maybe there's some summer thunderstorms that have dumped some rain. Southwest Kansas, southeast Kansas, north and southwest Nebraska, those are still looking kind of grim. But at least right here, things are looking a tad bit better, which is encouraging. But anyway, the point is, you've got this data at your fingertips. And for example, if we drill down there and again into southwest Kansas, and we've got all kinds of information, this is where it comes from the agricultural census from the U.S. Census Bureau, and you've got, and this is mind-boggling here, how much value that particular county is for livestock. Look at these numbers. I mean, they're in the millions of dollars. This one's actually over $1 billion. That's a lot of value there. So remember last week we talked about what's where, why is it there, and why should we care? So when I work with students of all ages, really, primary to university and lifelong learners like you all, okay, why should we care about this? Well, okay, this is the potential impacts on crops, livestock, people's livelihoods, soil, water, etc. So these are serious issues, right? And you've all seen, we'll talk about this in a moment, the severe situation with the Colorado River watershed. So why is that such a problem? Well, you've got this severe drought happening in central Utah. Again, a little bit better in northern Arizona than it was a few weeks ago. But still, looking at this kind of data, I think, is really fascinating. So closer to home, we look at Lincoln County, I think is what I clicked on. There we go. So, okay. How many agricultural jobs? What's the total sales like for this particular county? I'm not sure. We'd have to look at the metadata to find out if that's per month. Is that an annual figure? So it's important to ask questions of the maps that you're analyzing. Okay, so drought aware, just one particular, I think, very compelling view of the situation. And again, what's where, why is it there, and why should we care? We should care about these things. So back on the Living Atlas, that's just one of those apps. I'm going to explore one more with you. This was also part of the homework. But again, no worries if you didn't have a chance to look at this. But the World Imagery Wayback, I'm going to scoot these zoom controls around a little bit so I can actually see what you're seeing. But it's basically about an 8-year time period of literally terabyte loads of satellite imagery at your fingertips. So you can look at change over space and time with satellite images in the visible part of the spectrum. In other words, what your eye can see. So if we were able to lean over that satellite, what would the Earth look like from that satellite, in this case, mostly from Maxar here in Colorado. Digital Globe is their former name, but it's right here in Colorado, creating imagery for the planet and selling that to Google Maps, to us here at Esri and other people that want imagery. And the nice thing is that this Wayback Imagery web mapping application will give us a very nice user experience right away. So if I view application, now I'm going to be looking at, every one of these maps has a default view. And this particular one is, you probably guess, it looks like it's pretty arid, right? We can zoom in there. There doesn't look like there's any vegetation there. So we've got some short grass prairie that can't be Metro Denver because it looks like pretty much arroyos, canyons. Does anybody have a guess as to where this actually is?
Las Vegas.
Exactly. Well, thank you very much. or Priscilla. Anyway, that was my Elvis. But the point is, yes, it's Las Vegas, exactly. So we can see that, okay, we've got this big city, and as you folks know, it really wasn't that large until about the 1980s. It was sort of a semi-sleepy town. Okay, we could maybe argue about when it became a sort of a metro area, but it really hasn't been a metro area for more than about 2 generations. Okay, is this sustainable? Can we have cities like Las Vegas that are in this very dry environment, especially if we've got drought conditions and they're relying on things like surface water, for example, from Lake Mead? Okay, well, if we look at this, we're going to zoom in on a section of Las Vegas. You can also do this on your own device. But if I go to the upper left here, and there's a line with 2 arrows coming out of it on the left side. It's a swipe mode. Swipe. It's kind of like a big squeegee that you put across. It could be 2 different dates of a certain map theme, or it could be 2 different themes entirely. It could be land use on one side and land cover on the other, or vegetation on one side and river systems on the other. In this case, it's going to be 2 different years that we decide to place on the left side. So on the left side, I'm going to click on 2014, and on the right side, I'm going to click on 2022. So as you can see here, at the intersection of Durango Drive and the Bruce Woodbury Beltway, in 2014, there was a big field, probably some cholla, maybe some rattlesnakes, some desert beetles, and now it's a big IKEA store. So when you think about, okay, why do businesses locate where they do? We talked about this a bit last time when we looked at the Starbucks map. Remember that? We talked about a little bit of the threshold. A community has to be X thousands to get a convenience store, maybe X hundreds. Has to be, for years, the criteria, I might have mentioned this last time, for a Dairy Queen, especially in Texas, was 5,000. If you had 5,000 people, you got a Dairy Queen. And so then we talked about how big does it have to be to get a Home Depot, and then how big does a city have to be to get an IKEA. So they each have their thresholds, and they use geographic information systems to figure out where the stores are going to be located and which cities get one of these. So some of you remember when IKEA went in Denver, we thought, oh, well, Denver's got to be a big place now. We've got an IKEA. And so the customer shed, if you will, SHED, the shed for the customers going to an IKEA is hundreds of miles, right? Especially for a place like Denver and Las Vegas. There's probably not another one, unless there's one in Reno. I don't know. We'd have to look. But there's probably the only one in Nevada. And just like the one in Southeast Denver is for Colorado. That's the only one here. So, okay, now there's an IKEA at that intersection. So we've thought a little bit about, okay, they've got a big imprint. They got to have a lot of land. It's got to be accessible, not only for the delivery trucks, but for the customers coming there. It's not a neighborhood store. So lots of reasons why it's actually there and, locally, and then reasons why it's actually there regionally. Why did it locate in Las Vegas? Okay, well, we can see just the changes, not only there, but in places surrounding there. So if I pan to the southwest, and this is where we get to the what's where, why is it there, and why should we care again, you can see that not too many years ago, 8 years ago, this was, look at that. You've got some encroachment of development, and now you've got this water park right here in this part of Las Vegas, where it was basically, again, a field of beetles and rattlesnakes and some cholla and maybe some cactus. And now there's a water park. Again, you and I think of, well, where's the water come from for that water park? And also there's some lawn here. It's nice to have a lawn next to your water park, sure. But where's that water coming from? And all those trees, how are those trees getting watered? Or because if they were left alone, the landscape would look like this. So the point is, we've got this amazing amount of imagery at your fingertips. So if we zoom out a little bit and we actually pan over, you'd probably know where I'm going to next. If we pan over to Lake Mead, you can see the decline in the lake level. So we can check this out. Look at on the left side here. Again, I got 2014 on the left side and 2021 on the right side. You can see the left side. Wow, I've got on the left side, look, Boulder Harbor, there's this island, okay, and a little causeway. Now there is no island. It's totally connected to the shore. You see that down in here, or the south central part of this image. So right away, and this is the power that maps have, right away, you can see things with maps that if I gave you a table of data and a bunch of stats, those have their place and they're useful. But here, we've got all this imagery at our fingertips. And so the power of maps give you a lot of information in a short amount of space and time. And that's the power that maps have had for millennia, from the Babylonian clay tablets that we talked about last time to Ali Idrisi's map of silver from the 1100s. to maps of Magellan's original map from Holland in the 1600s or so.